Assalamu alaikum. We'll be reviewing some questions from October 2025, IAL Unit 1. So, the question is question number 8. Question number 8 says, what is the first ionization energy for hydrogen? Oh, sorry. The question says that the first ionization energy for hydrogen is 1312 kilojoules per mole. What is the ionization energy in joules that is needed per atom of hydrogen? What is the energy required, or what is the ionization energy for 1 atom of hydrogen, right? So this energy is for 1 mole, right? So 1 mole of hydrogen is equivalent to what? 1 mole of hydrogen is equivalent to 6.02 into 10 to the power 23, right? 1 mole of hydrogen, right? So I can write 1 mole of H equals 6.02 into 10 to the power 23 atoms, right? So this number of atoms will require this amount of energy, right? So if you have 1 mole of hydrogen, the first ionization energy, or the energy required for first ionization, is 1312. Now 1 mole of hydrogen is equivalent to 6.02 to 10 to the power 23 atoms, right? Now, this number of atoms, for this number of atoms, you need this much energy. So for 1 atom, how much energy would be required? For 1 atom, you must divide this energy by the number of atoms. So the energy is 1312. You have to multiply it by 1000 because you need to give the answer in joules, because this energy is in kilojoule, right? You divide this by the number of hydrogen atoms, which is 6.02 into 10 to the power 23. If you calculate this, the answer comes out to be 2.18 into 10 to the power minus 18. So the answer to question number 8 is B. B is the final answer. So now we move on to the next question. The next question is question number 11. Someone asked me to solve this question. Question number 11. It says 6.3 grams of cerium reacted completely with 1.439 grams of the oxygen gas, right? So let us look at cerium and let us look at oxygen. So this is the mass of cerium and this is the mass of oxygen. You divide by their respective atomic masses. You divide by 140.1, you divide oxygen by 16. So if you divide them, 6.3 divided by 140.1 will give you 0.0449797, and 1.439 divided by 16 will give you 0.08994. So you divide by the smallest number. Smallest number is 0.04497. 0.04497. So this comes out to be 1 divided by 0.04497. This comes out to be 1.9999, which is actually 2. Okay. So the ratio of cerium and oxygen is 1:2. So the answer to question number 11 must be C. C must be the answer. Alright. If you have any questions, you can write in the comment section and I will try to reply back. Then we move on to section B, question number 15. It is question number 15. 15C1, yeah. It says write an equation for the complete combustion of propane. Switching are not required. Propane has the formula C3H8. If you carry out combustion, this reaction will produce carbon dioxide and water. C3H8 produces 3 moles of carbon dioxide and produces 4 moles of water. And if you want to balance oxygen there would be 3 to 6 and then 4. I think you need 5 moles of oxygen. That would be the balanced equation for the reaction. Then it says, it's a very interesting question. The question looks pretty different, but this is a very easy question. It says, determine the increase in volume in dmQ of carbon dioxide gas produced per mole of butane. Increase in volume of carbon dioxide produced per mole of butane compared to per mole of propane on complete combustion. So the question says, if you burn butane instead of propane, right? You burn propane, right? Now if you burn butane, what would be the increase in the volume of gas, right? Now at room temperature, carbon dioxide is a gas, H2 is a liquid, right? So when we carry out combustion, the carbon dioxide, so the gas formed is actually carbon dioxide, right? So they asked about the increase in volume of carbon dioxide gas. When you burn propane, it produces 3 moles of carbon dioxide. But when you burn butane will produce 4 moles of carbon dioxide. You do not need to write the whole balanced equation. Figure this out. It's very easy. You don't need to figure out the whole thing, the whole equation. So when you burn propane, it produces 3 moles of carbon dioxide. Now when you burn butane, now since butane has 4 carbon atoms, when you carry a complete combustion of butane, it produces 4 moles of carbon dioxide. So when you burn propane, you are forming 3 moles of carbon dioxide. When you are burning butane, you are forming 4 moles of carbon dioxide. So the increase in number of moles is 1 mole of gas, right? Before you used to form 3 moles of carbon dioxide, now you are forming 4 moles of carbon dioxide. So the increase in number of moles of carbon dioxide is 1 mole, right? It's only 1 mole. Now if this is 1 mole, if it is 1 mole, then 1 mole is equivalent to 24 dmQ per mole, right? So the answer will be 24 cubic decimeters, because when you have propane, it produces 3 moles of carbon dioxide. When you have butane, it produces 4 moles of carbon dioxide. So there is an increase in number of moles by 1 unit. So 1 mole is equivalent to what? 1 mole is equivalent to only 24 cubic decimeters. Yeah, that would be the answer. We move on to the next question. The next question says, both pent 1 and pent 2 react with steam in the presence of an acid catalyst to produce alcohols. Yes, they react with steam to produce alcohols. Explain by referring to the addition of steam how both alkenes can produce the same alcohol but can also produce different alcohols. So the question is, how both alkenes can produce the same alcohol but they are able to produce different alcohols. Include the names and structures of all the 3 alcohols. It's a very easy question. So if you look at pent, if I draw pent 1 in for you, pent 1 in. This is the structural formula of pent 1 in. Let me draw pent 2 in. Pent 2 in is CH, double bond CH, CH to CH3. So that's pent 1 in. That's pent 2 in. If you react steam with pent 1 in, Now, if you react steam with pent-1, two possible products can form. It can form two possible products. Let me show you both the products. Two possible products can form because water has H and OH, right? So one carbon will get attached to H, the other carbon will get attached to OH, right? So one of the carbon atoms here will get attached to H, another carbon atom will get attached to OH, right? So what happens if the carbon atom, what happens if the hydrogen joins the first carbon and the OH joins to the second carbon, it produces pentane 2-ol because there are 5 carbon atoms in the longest chain, 1, 2, 3, 4, 5. And OH is now on carbon number 2, so this will be called pentane 2-ol. And if it's the other way around, it means if the OH binds to the first carbon and H to the second carbon, this will be called pentane 2-ol, right? This will be called pentane 2-ol, right? Now if we add H2O, if you react steam to pent-2, one of the products will also be pentane 2-ol. Because if the hydrogen binds to the third carbon and the OH binds to the second carbon, this would form pentane 2-ol, right? Because when you react alkene with water, it produces an alcohol where the hydrogen gets added to one of the double bonded carbon, the OH gets added to the other double bonded carbon. Now, if the hydrogen binds to the third carbon and OH binds to the second carbon, this would form pentane 2-ol. Now, if hydrogen binds to the second carbon and OH to the third carbon, this would form pentane 3-ol. Right? The hydrogen binds to the second carbon and OH binds to the third carbon. The compound formed will be pentane 3-ol. All right. So that is how you explain this answer. So you get 1 mark for drawing this, and you have to say that this can be formed from both the alkenes, from pent-1 and pent-2. So you get 1 mark for this. You get 1 mark for drawing pentane 2-ol. You get 1 mark for drawing pentane 3-ol. You get 3 marks from here. And you have to give the name of the alcohols. So you get 1 mark for all the correct names. You get 4 marks here. And 1 mark you will get because you have to say that when the alkene reacts with steam, the H and the OH can get added to the double bond. It can get added to double bond in either way around. What it meant that you can add a hydrogen here and OH here, and it can be the other way around, OH here and a hydrogen here. So you have to write that statement in words, right? So we write here when alkenes react with steam, H and OH can add to the double bond in either way around. So for this statement, you get 1 mark. So you get 1 mark for this compound. You have to mention that is formed from both the pen 1 in and pen 2 in. 1 mark for this compound, 1 mark for this compound, and 1 mark for all the correct names, and 1 mark for this statement. That's how you score 5 marks here. It was pretty easy to score at least a minimum of 4, right? Now we move on to the next question. Where's the next question? Copper 2 sulfate is an ionic compound. You are asked to explain or describe an experiment which will demonstrate the movement of copper 2 in an aqueous solution of this salt. I think we studied this. Oh, it's not required. It was not marked. You want me to solve the dot and cross diagram for you. It says dots for the sulfur electron, crosses for the oxygen electron, and triangles for the extra electron. So listen, the thing is, it has a -2 charge. Whenever such anions, when anions have a -2 charge, so you must remember the negative charges will be on the oxygen, and each oxygen will be having a charge of -1. There will be 2 oxygen atoms which will be negative. Whenever you have a charge of -2, it means 2 oxygen atoms are negative. Each has a charge of -1. And the negative oxygen atoms will form only single bonds. The negative oxygen atoms will only form single bonds. The other 2 atoms will form double bonds, because oxygen usually forms double bonds. They don't form single bonds usually. Oxygen usually forms double bonds. So what we'll do is, we'll form single bonds according to the overall charge. If the overall charge is 2 minus, so we'll form single bonds with 2 oxygen. If this was -3, we'll form single bonds with 3 oxygen atoms. If this was -4, we'll form single bonds with all the 4 oxygen atoms. If the overall charge was -1, we'd form single bonds with only 1 of the oxygen atoms and double bonds with all the others. Now, since we have a charge of -2 here, we'll form single bonds with only 2 atoms. So single bonds with 2 atoms, all right? So let us draw a single bond with 2 atoms. So it's dot for sulfur, right? So let us draw a dot for sulfur. So that is 1 dot for sulfur, and we need a cross for the oxygen. So that's a single bond. So there will be 2 single bonds, right? But for others, we'll have double bonds. We'll have double bond for the others. Okay. And then you have to give cross for the oxygen electrons. So this oxygen will have 4 more electrons, because the total number of electrons around oxygen cannot exceed more than 8. So we have already shown 1, 2, 3, 4. So we can show 4 more electrons. And oxygen in the outer shell, it has only 6 electrons. So you cannot show more than 6 crosses, because one oxygen atom in its outermost shell has only 6 electrons. So you cannot show more than 6 crosses, right? So 4 more crosses here. So the total number of crosses will be 6. And here we have 1 cross. So you can show 6. You have to show 6 crosses. There's 1 cross. There's the second one, the third one, the 4th one, the 5th one, and the 6th one. So this oxygen is 1 electron short. So it will get an electron from outside, which is the extra electron, which is shown by the triangle. For this atom, for this extra oxygen atom also, it has only 1 cross. That is the first one. So then we have the second cross, the third cross, the 4th cross, the 5th cross, and the 6th and the 5th cross. 1, 2, 3, 4, 5, 6. Yeah, sorry, 6 cross. 1, 2, 3, 4, 5, 6 cross. So this oxygen is short of 1 electron. So it will get an extra electron from outside, and that is the correct dot and cross diagram of this compound. Of this anion, of the sulfate ion. Okay. Now we move on to the next question. Question number C1. It asks which salt is in excess. So since they asked which salt is in excess, you need to find the number of moles and check which of them is in excess, right? So you need to find the moles of ammonium sulfate. You have to find the moles of ammonium sulfate. Ammonium sulfate will be 3.35 divided by molar mass. Divided by the molar mass is 132.1, which is equals to 0.025360. Then you have to find the number of moles of copper to sulfate. Copper to sulfate is a mass of 3.96. You divide it by the molar mass of copper sulfate, which is 159.6, and it is found to be 0.024812. All right. So definitely ammonium sulfate is in excess. So therefore NH4 is in excess because it has slightly greater moles. Then we move on to the next question. It says the crystalline salt prepared is hydrated and has the formula NH4 2 CuSO4 2.6H2. The mass collected was 9.52 grams. Okay. Calculate the percentage yield of the double salt from this preparation. Mass collected was 9.52 gram. So 9.52 gram is the actual yield. So we need to find the theoretical yield. Now, how do we find the theoretical yield? In order to find the theoretical yield, we need to calculate the moles of the salt formed. Moles of the salt will be equal to mass divided by we already know the we actually already know the moles of the salt because all have the mole ratio of 1:1, right? Now the limiting reagent is copper to sulfate. You have to use the number of moles of copper to sulfate. The number of moles of copper to sulfate and the number of moles of the double salt is the same because the mole ratio is 1:1. So what we would write here, moles of the double salt formed, moles of the double salt will be equals to the moles of copper to sulfate. Now the mole of copper to sulfate was 0.0248, right? It was 0.04812 or 0.0248. So from here you find the mass of the double salt. How do you find the mass of the double salt? What you do is you multiply this mole multiplied by the molar mass. Now the molar mass of the double salt is 399.7. You have to calculate this from the formula of the double salt. So you get 399.7. If you multiply, you get 9.9125 grams. So then you find the percentage yield. Percentage yield is actual yield divided by the theoretical yield. So the actual yield was 9.52 grams. 9.52 grams divided by 9.9125 multiplied by 100. This will give you 96.039%. This would be your final answer. This is the percentage yield. All right, thank you.